Thank you. I guess good afternoon, good evening, good morning to all the attendees. Um, I'm here today to talk to you about some of the new developments around the Oracle database with Kubernetes and microservices. And my name is Wei Hu. I've been at Oracle for quite a while. I work on high availability technologies. All right. So before I start, I just want to say that we are starting this year this event called the Oracle Database World. Okay. And in fact, the talk I'm giving is the same talk that I'll be giving at Database World that's going to start today in US time, right? And Database World is think of it as open world for databases. And we'll have our executive vice presidents, Juan Loaiza and Andy Mendelson, along with basically the senior technical people telling you what's going on with Oracle database, what's coming, and so forth. So, and the sessions for Americas is happening today. The one for Europe is going to be next week, okay, and then Japan and so forth. So I strongly suggest that you sign up for these sessions. In fact, if you want to stay up late today, you should attend the America session. Otherwise, I would say attend the European session in time. And some of this, and in my talk today, I also give you some pointers, some additional talks in database world that you might be interested to follow up to learn more. So, all right, so going back to the topic about Kubernetes and microservices. I have a love-hate relationship with Kubernetes. I think it's wonderful technology, but I still think it's quite hard for people to adopt. And there's a survey here that just says that 77% of organizations consider Kubernetes as a central part of their digital strategy. So they think it's hugely important. Okay, and we see that Kubernetes is becoming the standard for deploying containers in production, and developers are really embracing it for both new and existing applications. And in the context of this talk, we also see that many microservices applications are deployed in containers managed by Kubernetes. So that's a good sign. The next side is that you have quotes like, guess what? Kubernetes in production is hard. And in this talk, I would describe how Oracle is really embracing and innovating into space to make it easy for you to develop enterprise class applications on this technology. To start with, I just want to go bottom up and start with containers, right? And just state that Oracle Database 19c is fully supported in Docker, right? And when I say Docker, I also mean Podman and so forth. Okay? And we are releasing Docker container images for Oracle Database, all the varieties, Enterprise Edition, SE2, single instance, rack, and sharding, and they're available at the Oracle Container Registry at that URL there. And these images are supported for production use. If you run into issues, you can call support and we will address your issues. Okay. Now, rack is special in that rack container images are supported for only on premises. Okay. We recommend that when you deploy rack in the cloud, you use Oracle's managed cloud services, such as the Autonomous Database, Exadata Cloud Service, and so forth. And the rack images, rack containers are supported, assuming that underlying operating system hardware and so forth also support for rack. Right, and we release these images with the expectation that you can patch them and use them as your own gold images. So we release Docker images for the base release, like 19.3, right? And in addition, we publish all the Docker files and scripts that we use to create these images, and we push them onto GitHub. What this means is that you can take the same scripts and Docker files that we use to create these images to create customized versions of these images for your own use. That's number one. Next, you can take these images and deploy them in Kubernetes. Right? And you can deploy them in Kubernetes using Helm charts. Charts is really a metadata that describes, that tells Helm how to install container images for complex applications. You think about rack has multiple instances, you have shared storage, you have networking, and so forth. So all these described by charts, you can just pass them to Helm, and Helm will just configure for you. Okay. So for example, here is a Helm command that installs the Oracle Database 19c using the default configuration. And likewise, we publish our Helm charts on GitHub so that you can, again, use and extend the tools that we use to create and provision these images. And so the question comes, there's actually a lot of Kubernetes distributions out there. So what do we test? What do we support, right? And so first off, we build our images against standard interfaces. Okay, there's this common container runtime interface that we use. Okay? And then we test and certify on the Oracle distribution of Kubernetes. It's the Oracle Linux container, cloud native. So basically, it's a CNCF certified Kubernetes distribution. And based on feedback from customers like you, we know that Red Hat OpenShift is very popular, so we support these images in Red Hat OpenShift. And we use what I call the trust and verify principle, which means that Red Hat OpenShift supports the same standard interfaces that we do. So it should just work. Okay. But we will still do sanity checks using the same Red Hat OpenShift releases as for Oracle Linux. Just to confirm that yes, indeed, it works as advertised. Okay. And there's a support note that describes the details of how this works. So being able to run Oracle containers, being able to deploy these containers in Kubernetes is good. But we also want to make the Oracle database what I call Kubernetes native. Right? And basically, we want to make the Oracle database natively part of the Kubernetes infrastructure. That means you can start, stop, monitor, patch, upgrade, and perform other lifecycle operations always in Kubernetes. Okay? So, for instance, you may want to issue a Kubernetes command to start an Oracle database. Right? And we want to make this work whether the Oracle database is running inside the cloud, on premises, inside a Kubernetes cluster, or even outside of Kubernetes. Because we understand that for a lot of our customers, they may choose to deploy their mid-tiers, their applications in Kubernetes, but maybe the database in the cloud or on premises, outside of Kubernetes, right? And we want to make all these configurations work within Kubernetes. And we believe, actually, we know that there are really two aspects to this. The first part is to make the Oracle database natively observable in Kubernetes, right? And the second part is really is a Kubernetes operator for the Oracle database. And I'll talk about both of these. First, observability. One of the things that I really love about Oracle is that the database has so many rich performance and runtime statistics. There are all these VDollar views and Ash and tools to see so you know exactly what's going on, right? And what we're doing is we're making this data accessible via popular open source frameworks that are often used as Kubernetes. Okay. For example, Prometheus. We know that Prometheus is a very popular metrics open source tool, right? So what we're doing is we're providing extensions to Prometheus. They're called exporters to publish database metrics. We're also working on best practices for using Loki to monitor and aggregate activity from the application to the data tier. Right? So you can look at the application end to end together, right? And of course, once you put data in Prometheus, you can look at them through Grafana, right? So we are also providing Grafana dashboards to display this data. And our goal again is to support Oracle databases within and without of Oracle, because these open source tools are often used by themselves. So that means they can be used with Oracle databases anywhere, inside Kubernetes or outside. And our goal really is to allow you to monitor and trace the entire application end to end using native Kubernetes tools and dashboards. And all of this stuff is being published on GitHub also. So that's the first part. First part is native observability. The second part is really the Kubernetes operator. So if you're familiar with Kubernetes, operators are extensions to Kubernetes to manage applications. It allows you to use Kubernetes command line, kubectl, to manage the lifecycle of Oracle database. So for instance, this kubectl command is a Kubernetes command that basically provisions an autonomous database. So as I said before, our goal is to make this work, wherever the database can be. Actually, so let me back up. Okay, so the operators we're providing can manage Oracle database and running anywhere. They can be running inside Kubernetes clusters, outside of Kubernetes. They can be running on premises or in the cloud. They can be running in the same or different clouds. And the way we do this is by providing multiple backends to the operator. Okay, so we have a single operator that have multiple backends called controllers. And these controllers manage the different types of Oracle databases. And our goal is to really make the Oracle database deployed anywhere, natively manageable by Kubernetes. And this is how architecture, how it works, right? You have a Kubernetes cluster, right? And then you can run the kubectl command against things in the cluster. You can look at things, you can do things with them, and so forth. Right? In particular, with the Oracle database operator, right? We have 3 controllers. So one controller basically manages Oracle databases running inside Docker containers in the Kubernetes cluster. Then we have a different controller that manages databases running in the Oracle Cloud, the autonomous database. Then we have a third controller that manages the on-premises databases. And we want to provide the lifecycle operations that you expect: provisioning, so forth, backup restore, scaling, patching, upgrade, monitoring, logging, and so on. Okay. So this is the big picture. Now, we're releasing this over a period of time, right? So here's oops, let me back up. All right, I'll talk about it a little later. What's here today and what's coming tomorrow. Okay. So notice how here I talk about both things running inside the Kubernetes clusters as well as things running in the cloud, right? And we think that's important because we think that Exadata and the autonomous database service is really the simplest way to use Oracle, right? We think that for the ultimate simplicity, instead of trying to manage inside Kubernetes, just run the Oracle database in the cloud, right? And then you can use a database service while using Exadata database service. You get to use the best database platform, Exadata, right? And furthermore, with autonomous database, everything's automated for you. And again, with Exadata autonomous database, you can deploy it in the Oracle public cloud or in your data center with a cloud custom model. Right? So earlier I talked about the roadmap. So available now, in fact, we announced it yesterday, is support for autonomous database. Right? So we have a database operator called Aura operator, right? That can manage autonomous database. You can manage Oracle database running inside containers. Okay, single instance database running Enterprise Edition, Standard Edition 2, and XE, as well as a sharded containerized database. Okay, so all these were publicly announced yesterday, and they're available now for download at GitHub. Sorry, at the Oracle container GitHub and so forth. Okay. Then over the next calendar year, we're releasing backend controllers for the other flavors of autonomous database: dedicated ADW, autonomous JSON database, Apex, for the DBC as a VMDB in the cloud, rack containerized databases. Okay, so this can run inside on-premises on the cloud. On-prem databases, including Exadata. So you can see that this is what we're doing, we're just rolling out different backends of the controller and making it more powerful over time. And our plan is to test on major Kubernetes distributions as well as third-party clouds. So the initial releases that we're doing runs on the Oracle distribution of Kubernetes for both on-premises on Oracle Linux as well as in the Oracle Cloud called OKE. And you can learn more about this at the Database World sessions that are coming up. And there's a session called Oracle Database Kubernetes Operator, where you should care by Kwasi, which goes into much more detail about how all this works. All right, so I want to summarize, which is that, as you can see, we are really going full in with support for Kubernetes. Right? We're really embracing the use of containers in Kubernetes. We start by supporting container images for production on both Oracle and non-Oracle infrastructure. Right? We're releasing the Helm charts for configuring the images in Kubernetes. We are providing adapters for Kubernetes open source observability. Things like Prometheus and so forth, Grafana and so forth, for observability tracing. And we've just released the operator to allow Kubernetes to manage Oracle databases, right? Whether it's running inside a container or external. And all of these are open source and available on GitHub. Okay, so I think with all this, I think we are first-class citizen, really fully embracing Kubernetes. Right? But we're not stopping there. Right? What we really want to do is to really innovate and extend the containers in Kubernetes to support high-end OLTP. And the challenge that we're dealing with is really supporting mission-critical microservices. And I think this quote is very interesting. It's a reality check. Okay? Even though Kubernetes, this is based on the CEO of Volterra. So even though Kubernetes has become a red hot trend among tech media and influencers, few organizations are actually deploying Kubernetes for critical business applications. Yeah. Why is that? Okay, so I think one thing is just complexity of technology. The second one is really the lack of transaction support. Right? Real-time, high-throughput OLTP applications traditionally use transaction monitors, such as Oracle Tuxedo and IBM CSCs. And transaction monitors are what's used today to do things like money transfers, credit cards, reservation systems, and so forth. And so if you're building a microservice application and want to deliver the same level of performance and reliability, you need some of the capabilities that don't currently exist. So here is a preview of what we are doing. This is coming. And the reason I'm talking about this is to let you know it's coming. And also, if you're interested, contact us to get early access to technology because we're looking for early adopters. What we're doing is we are providing distributed transaction support for applications deploying Kubernetes. And we will provide strong consistency with XA try-confirm cancel transactions. And we will provide eventual consistency with Saga orchestration. And we'll support popular programming languages and framework, Java, JavaScript, C, C#, C++, Golang, Python, as well as Apex. And key is this: these transaction management services will be deployed and managed as a native Kubernetes service. So it will be deeply integrated with Kubernetes, it will integrate with Istio service mesh, logging, monitoring, tracing. So we're really serious about how bringing transaction processing capabilities into Kubernetes. So again, this is a preview. If you're interested in doing this, let me know, and we'll be interested in talking. Okay. So now that I'm talking about Kubernetes, I want to step back a little bit and talk about the bigger picture of microservices architectures. Actually, microservices, in some sense, are sort of like Kubernetes. It's very attractive, but it's still hard, right? And the journey to adopt microservices is replete with failures. And here's a quote: expect to see more microservices failures as teams continue to struggle with them in 2021. This is very recent. Okay? And if you do a search on the web, you see various common questions. Why many microservice projects fail? 11 reasons why you're going to fail with microservices. Why do microservices projects fail to deliver? Okay? This is horrible, right? And I tend to try to focus on success. Given that there's so many things that fail, I just want to figure out what does it take to be successful with this technology, right? And I think there's really two key aspects. One is use the best tools available, and obviously that's the Oracle database. Right? And secondly, follow proven architectural patterns. And I think that's really important. Do what works, right? Follow the patterns that work. Okay. So I'll start with talking about the best tools available, how Oracle database supports microservices more. First one is multi-tenant, right? So containers simplify the deployments by enabling rapid and lightweight deployment of logical systems instead of physical systems. That's what containers are, right? They're logical. Oracle implements container concept natively in the Oracle database. Okay. This means you can deploy lightweight pluggable container databases. Instead of deploying and managing physical database, which microservice, you use pluggable databases, right? And the idea is that many pluggable databases can be deployed on a single physical database, and that simplifies operations, right? Because now because you manage things like backup recovery and so forth at the physical database level, that in turn allows you many pluggable databases as one. And furthermore, pluggable databases can be easily cloned and moved between physical databases. Right? So that gives you the mobility and so forth. And to encourage adoption, the use of pluggable databases, now with database 21C XE, the free edition, right? You can now have unlimited pluggable databases. Okay? Because we think this is really important. We really want to promote the use. So multi-tenancy is a key part. It allows you to manage, lightweight, pluggable databases. Next is support for transactional events. So Oracle has transaction event queues, right? This is previously called Advanced Queuing AQ. Transaction Event Queue is basically the re-architected version of AQ. It's a free event platform built into the Oracle database and has been there for 20 years and has been continuously enhanced. Okay. And TEQ, or Transaction Event Queues, makes developing microservices simple. Why is that? Key things are, number one, it makes the publish and the consumer of events is transactionally integrated with data changes. So you can publish an event, make a data change, and the whole thing is an atomic transaction. So this means you can handle difficult cases like events that change database state and produce more events. It provides very strong exactly one semantics without two-phase commit and item posted issues. And of course, this means that the security back recovery of events and data tied together. So when you recover an event, you get the data back at the same time. And again, events are really important because in a microservice architecture, each microservice is loosely coupled and they communicate using events. And TEQ has a scaled architecture that can handle over 1 million events per second. And TEQ also supports this concept of transactional cross-database event propagation, again, without two-phase commit, because again, two-phase commit has a lot of overhead issues. And if you want to go to connect to external event systems like Kafka, you can also, there exist adapters like Confluent provides these source sync connectors to allow you to ship events between Kafka and TEQ. And TEQ is used by tens of thousands of enterprises. And you can get more details of how this works in this database world session about transaction events with Oracle TEQ in the database and how it interoperates with Apache Kafka. Okay, so I strongly advise you to, well, first of all, sign up for Database World. And after listening sessions, look for this session. So I talked about what Oracle Database has to support microservices, right? Why it's the best for microservices. And now I want to talk about patterns. And again, I want to emphasize that I strongly believe the use of proven architecture patterns is crucial for success with microservices. And we work hard to make sure that we can examine these patterns and how we can simplify them. And Oracle Database simplifies what I call 5 key microservice patterns. And these are the 5 patterns, right? And you can look them up and see what they do. And I'll just give you a very brief summary of how that works. The first pattern is what's called a transactional outbox. And so the idea is that with this pattern, you can write data into a table and publish an event as a single transaction. And you can imagine this is a very complicated pattern because it involves application code, making sure that the update event publication are atomic. And this is actually complicated if you don't have infrastructure, right? So as I mentioned before, we have transaction event queues. TEQ simplified transaction outbox by atomically persisting the DML event. Right? So basically, TEQ means we have built-in transaction outbox into the system. So you don't have to write your own code to do this. Right? And TEQ will maintain total ordering within each event stream and recover from any kind of failure, same as database recovery. And that's important because failures are what really kills functioning systems. And we provide exactly one's delivery of events. Right? This makes the application code simple because you don't have to write a complicated logic to ensure all this stuff works. And here's a picture of it, because it's really hard to explain how simple things are. And so what I tried to do was to create a diagram. This is actually from a hands-on lab. Okay, so we've created a hands-on lab that shows you how to write microservices with Oracle Database. Right? And if you go to this URL, there's this hands-on lab that shows you how to write this application using non-Oracle databases. So in this case, it uses a generic event system and with non-Oracle databases. And then this blobs is basic code that you have to write. So there's the order services inventory system, and you have to write code to handle item producer to prevent duplicates. You have to write code to make sure that the table update and the events, can handle duplicates, can detect failures and so forth. On the other side, you have the concept of the consumers of the event to make sure you prevent duplicates, and again, and there's other stuff you have to do, right? So this is all code that you have to write in your application to handle these cases and implement the pattern correctly. Okay. And here on the right-hand side is what it takes with the Oracle database. Okay, with TEQ building the Oracle database, you can see that all the code is gone. Okay, you don't have to write this code because it's built into the database. Okay, so that, I think that's great. Okay, because simplification is no code is wonderful because no code means no bugs. not only is it less work, it's no bugs. So it's a huge amount of simplification. Okay. So this just illustrates what transactional outbox and item to consumers including the Oracle database gives you. All right, so the next pattern is really the idempotent consumers that I mentioned briefly. Okay. And the reason this pattern exists is because in real systems, events can be lost or duplicated. Right? Because if you have network connectivity issues, or if a server crashes, comes back up, you may resend everything or may lose stuff, right? To handle these cases, event consumers must be idempotent, which means that they must detect and ignore duplicate events. So for example, you have an ATM machine and I get two different requests to withdraw $5,000, I want to be really careful to make sure they're really two separate events and not the same withdrawal just sent twice. Right? And the Oracle database, the Convert database, simplifies the idempotent pattern for microservices by supporting strong exactly once event delivery. Okay? Because many people claim they support exactly once, but it turns out they don't handle some failure cases. But we do. We handle crashes, network failures, point-in-time recovery, failure with disaster recovery silence. It just works. Okay? And this is easy to use and does not require distributed two-phase commit. And there's some technical details, but Kafka claims to have at most one semantics, but in fact, it doesn't work when the producer session crashes, and it requires extra consumer code to do stuff. And so the fact that we built this into our database means that consumers of our event system do not need to do any deduplication. You're guaranteed to get an event. That's it. You're not gonna get it duplicated unless you ask for it again. The third pattern is event sourcing. And that's actually an important topic, so I want to review some concepts. Actually, for you guys, it would not be a review because you wouldn't have seen this session. Right? So the Oracle database supports what are called both application coded events and data events. Right? Because we use the term events very loosely, but turns out actually two kinds. Right? The type of events supported by TEQ, transaction queues, are what are called application coded events. The application coded events, because the application logic needs to define what the event means, needs to handle the event processing. So data events, on the other hand, are state changes that are published to keep peer microservices synchronized. So that data events are sent when the data is changed. So for example, the price has changed. So data events, because it reflects change in data, so not like coded events, which has to be handled by application logic. Data events can, and in fact, should be handled automatically. Because if the data change, we can handle that, right? And by handling automatically, you avoid expensive error-prone hand coding of state change capture that can lead to data consistency. If you handle data events with custom code logic, if you have a bug, the data is not transferred or correctly, and you have data divergence, right? Inconsistent data. And so this is where Oracle Golden Gate comes in for data events. Oracle Golden Gate can automatically capture, transform, publish data events to hundreds of target types. And furthermore, the entire process of capture, transmission, publication is automated. You can do in parallel, and it's transactional to ensure both high performance and consistency. Okay, I think that's a great combination. And what this does, it makes Golden Gate the ideal infrastructure for developing a data mesh. So data mesh is a new term that's been used for this, for handling data events to large enterprise. And I say here, please review, but this talk hasn't happened yet. This talk is going to happen at Database World. So please go to this talk. It's a talk by Juan Loaiza about how do you rethink how you use the Oracle database architecture to embrace modern application development. I think it gives you a much larger picture of how all this works. Event sourcing. Okay, so now with this setup about how explaining what events are, application code events and data events, we'll talk about event sourcing. Okay. Now, with event sourcing, you store operations as a sequence of events. Events are recorded in an event store and can be replayed to create data for new sessions. And the Oracle database simplifies event sourcing for microservices by supporting both application coded events and data events. So we support both types of events. We support both application code events and data events. For coded events, we recommend using transaction event queues to benefit from all the transaction consistency that I talked about and how it simplifies the various patterns, right? And if you need to, leave the Oracle ecosystem, use Kafka connectors to transfer coded events being Oracle TEQ and Kafka, and that supports heterogeneity and so forth. That's coded events. For data events, use Golden Gate to publish and consume data events in real time. Right? And Golden Gate allows you to publish events between microservices, between different applications, between public clouds. Okay? And so this actually is an interesting way to support multi-cloud data meshes. And Golden Gate can also move data between operational and analytic systems. And this gets to the last pattern that I want to talk about today, which is CQRS, Command Query Responsibility Segregation. And the idea is that you can use separate databases or models for commands, which are transactions and writes, and queries, which are analytics and reads, so that they can be independently scaled using an event store. So for example, this might be your where updates go, and this might be where all the reads and analytics go. Okay? And so this way you need to scale analytics out, you just scale the analytics databases and so. And when I talked earlier about how we natively support data events, this really simplifies the CQRS pattern. Right? So to start with, you can use separate PDBs for transactions, the writes, as well as the reads. Right? So for example, if you're in the cloud, you can use autonomous transaction processing for commands, the updates, transactions, and then use autonomous data warehouse for the queries, analytics. Right? So that's a very natural way to create the CQRS configuration. Then you can use Golden Gate as data mesh to create and making replicas for the analytics and reads. Right? So you can use Golden Gate change capture to create multiple copies for creating read replicas and so forth. And this is simple, it's fast, and it's consistent. And Golden Gate is the market technology leader for data events and replication. It's trusted by thousands of enterprises, including yours. And 80% of the global Fortune 100 uses Golden Gate. Oh, I apologize. I have one more pattern, but this is coming. So this is something we're working on. And again, this is giving you a preview so you understand what we're doing. And if you're interested, talk to us, and we'll tell you how to use it, be an early adopter. So Saga is a distributed transaction protocol for data consistency across multiple microservices. That's how it is. It's an interesting model, but it seems to be very popular with microservices. And we simplify sagas for microservices by implementing database, similar to what we've done with transaction processing, TEQ, transactional event queues. And by doing this, we actually hugely reduce the code complexity. Okay, we did some sample application changes and so forth. And we believe that we can reduce 80% of the code because of the compensation logic that's required to handle failures. And with all this kind of stuff, the normal case is easy. It's the failure handling that makes things horribly complicated. And basically, we're trying to reduce the failure cases. So this is something that's coming, and if you're interested in learning more about this technology, contact us offline, and we'll follow up. All right. So I'm going to wrap up by talking about summarize what the big picture looks like. Yeah. We are really talking about building microservices and Kubernetes with a converged Oracle database, right? And I think these three pieces go together. And what we're trying to do is create a modern data-centric application development and data DevOps platform. So we may have containerized microservices running, using a variety of programming languages, right? REST, Java, Python, and so forth. We're offering you transaction management support, right? So we can bring transactions into the Kubernetes environment. And all of this is natively observable using Grafana, Prometheus, metrics, logs, tracing, and so forth. Right? Then we have started providing these database operators, right? Such as in Kubernetes, you can manage the Oracle databases. They can be running anywhere, right? And the Oracle database, of course, are running multi-tenant so that you can natively support, virtual database containers. And so like the autonomous database can be managed by the Oracle database operator. Likewise, and what's interesting is I draw this picture here as if it's all running inside Kubernetes, even though this is running in the cloud, right? And that's because the operator, makes it look like it's part of Kubernetes. Right? Then the Oracle database supports two important technologies. One is TEQ for transaction event queues to support coded events. Right? Then Oracle Golden Gate to support data events. And together, these three technologies, not only do we natively support Kubernetes and so forth, we also make it much simpler to deploy many of the important microservices patterns, right, that I talked about. And you can find out more about this there's a URL that's basically microservices landing page in developer.com that tells you more about these technologies, has hands-on labs and things that you can try. Okay, so I just wanted to reemphasize that the Oracle database world is happening. There are several sessions that I think if you're interested in this topic, you can find out more about, transaction event queues, Kubernetes operators, workflows, AQ messaging, and a hands-on lab. All right. And in fact, you don't have to wait for the Oracle. Actually, the nice thing of doing a hands-on lab at the database world is that there will be people there to help you answer questions and so forth. But if you just want to run through the lab yourself, they're available. You can just download, you can just run them there directly at this URL. And with that, I guess I just want to remind you that you can watch Database World today if you're willing to stay up longer, or if you want to watch it, participate at a more comfortable time for Europe, it'll be November 2nd and 3rd. And here's a link to find it. In fact, just do a search in your browser for Oracle Database World, and you can get there and you can register. And I strongly suggest you do that. With that, I guess I'm done, and I'd be happy to answer any questions.